These are the notes for Unit 5, Lesson 2, and we're going to start looking at how to solve quadratics. We're going to take a look at two methods in this lesson, and then our next lesson we'll take a look at two different methods. Each of them has a purpose, a situation when it's best to use that, factoring, square rooting, quadratic formula, whatnot. And then at the end we're going to kind of mix them all together so you can look at a problem, know, okay, this is a problem where I should use the square rooting method or whatnot. All right, so like I said, today we'll take a look at factoring, solving by factoring, and then our square root. So factoring, when do you use it? When the quadratic is easily factorable. If you look at it and you have huge numbers that you're not able to factor, or if it's not even factorable, you're not going to use this method. All right, so remember, when we're solving a quadratic, we're looking for two x values. And since it's an x squared, we're looking for 2. Every now and then you'll get 2 that are the same, and that's okay. We'll talk more about that later, but we're looking for 2 answers. And if I were to think about this on a graph, your solutions are where that quadratic is crossing the x-axis. Now, keep in mind, not every quadratic does cross the x-axis. So in that case, we still can solve it, but we're going to have imaginary solutions. We're going to have i's in our answer. And since we've gone ahead and learned about our i's and our complex numbers, that is a valid situation to come across. All right, so factoring, when to use it. Once again, when you can factor. So our directions are pretty simple. Factor it completely, and then set each factor, even a variable GCF, equal to 0 and solve. And you'll see what I mean by that variable GCF shortly. One thing I didn't put on here that I need to make sure I point out is before you factor, make sure you move everything to one side of the equation, of the equal sign, if it's not already. It doesn't really matter if you move everything to the left or to the right. I like to keep my x squared or b squared, whatever letter, positive because I think it's easier to factor. So wherever that ends up being a positive is the side I typically move things to. All right, so make sure you make a note of that. Move everything to one side. If it already is on one side, then you don't have to worry about this. But you need to have it equal to 0. All right, let's go ahead and take a look at the example. And of course, I had a typo on here, so we're going to have to change our numbers because right now this is not factorable. I switched up the 7 and the 10 in my head. So let's cross that off and write this. This is what I meant. X squared minus 7x plus 10 equals 0. All right, so solving by factoring. First, as always, when factoring, look for greatest common factor. I don't have anything besides 1, so it's not going to help me. So since my coefficient of x squared is 1, I can just immediately jump to my factors. I need two numbers that multiply to 10 and add up to -7. If you said -5 and -2, you are correct. -5 times -2 is a positive 10. -5 plus -2 is -7. All right, so now it's completely factored. There's nothing else I can do. So I'm going to go ahead and set each factor equal to 0 and solve each equation. So x equals 5 and x equals 2. Now, if you remember from the last lesson, we said the factors and zeros are opposites of each other, and that's still true here. If you notice, my factor was x minus 5, and my 0 or solution or root, all the words mean the same thing, is a positive. Okay, and same thing for the 2. So for solving by factoring, if it's factorable, just go ahead and do it. Put your factors equal to 0 and solve. And that's all there is to that. All right, the other method we're going to go over again today is square rooting. When do you use square rooting? This is a good method to use if there is no middle term. So if quadratic has no x's that aren't squared, meaning there's no b term in there, no plain old x, okay? You could still use other methods to solve these, but this is an easier one if you recognize that you can use the square root method. So what we want to first do is isolate the x squared, undo any addition or subtraction or multiplication or division that is by your variable, and then square root both sides. Please don't forget that you need to take the positive and negative square root. Remember, a quadratic should have 2 solutions. And then, of course, simplify when you're taking the square root. If they're perfect squares, just take the square root. If you have to simplify into radical, whatever it may be. So let's take a look at this example. Okay, so I'm going to start by moving the 25 over. So adding 25. So I get 4x squared equals 25. Now the x squared is not isolated yet. So let's go ahead and divide by 4. Now, we know I can't do 25 divided by 4 and get an even number, so just leave it as this for now. Okay, so now that my x squared is, or my x squared, I can go ahead and take the square root, making sure I take the positive and the negative. Now this one's pretty simple in the terms of both 25 and 4 are perfect squares, so I can just go ahead and take the square root and get 5 over 2. So that means that I have the positive 5 halves and negative. You could write those separately, or you can just write it using the plus minus sign. All right. Now, guys, I do want to show you something, just so we're all on the same page here. I can solve this one by factoring. That is a difference of perfect squares. The square root of 4x squared is 2x. Board's a little funky today. Then minus 5 plus 5. So if I set each of those equal to 0, I get 2x equals 5, x equals 5 halves, which is what we got. Or 2x equals negative 5, so x equals negative 5 halves. So you still could solve by factoring, but not everyone's going to be a perfect difference of squares. Just sometimes you're going to get numbers that aren't perfect squares. But this is the same answer, okay, because the factors look like that. So if there's no middle term, we can square root. Okay, let's take a look at some of the practice. Okay, we're going to do these 4 together, and then I'll have you try I think there's 4 in the back. Yep, on your own. So let's first identify which solution method and then go from there. So looking at number 1, do you think we should use square rooting or factoring? Yes, square rooting because there is no middle term. There's no x term. Okay, I couldn't factor that, but we don't, you don't have to. All right, so I'm going to move my 1 over. So that equals a positive 1. And divide by 36. All right, now when I go to take the square root, it's going to look ugly, but hey, once again, 1 and 36 are perfect squares. So when I take the square root, I get x equals positive or negative 1/6, because the square root of 1 is 1, and the square root of 36 is 6. All right, let's go down to number 2. Okay, which method? So hold on, we did square root here. This one we're going to have to factor. Why? Because there's an x term. All right, and then we're going to take a look at next class. Well, what do you do if you can't do square root, but you also can't factor? We'll dive into that next time. All right, so I have a coefficient here of greater than 1, so I can't just jump right to my factors. I'm going to have to do some work. So 2 times negative 3 is negative 6. So I need 2 numbers that multiply to negative 6 and add up to negative 5, and those are going to be my middle terms. I'm breaking up that middle term. So it's going to be negative 6 and a positive 1. Right? Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. All right, and now I can go ahead and group. So I'm going to group these 2 together, the first 2, and the next 2. So here I can pull out a 2x, leave me with x minus 3. And here all I can take is a 1. Remember, you want what's inside the parentheses to be the same. Okay? So I've got 2x plus 1 is a factor, the loners. Right, so now go ahead and set them equal to 0. 2x plus 1 equals 0. X minus 3 equals 0. So I have 2x equals negative 1. X is equal to a negative 1/2. All right, so the factor 2x plus 1 is negative 1/2 in terms of a solution or a 0. And x equals 3. Okay, it's okay to get fractions, guys. That's fine. Not everything's going to be a perfect, pretty whole number. So negative 1/2 and 3 are my answers. All right, let's take a look at number 3. First, before we even get started, I forgot to make it an equation, sorry. So put that equal to 0. Otherwise, we can't really solve it if it's not an actual equation. All right, factoring or square rooting? Definitely factoring. Okay, now notice I have a GCF here. First of all, that's an x cubed, so I can't use my quadratic techniques yet, but I can pull out an x, leaving me with x squared minus 8x minus 20. All right, now I need to factor the trinomial. The coefficient's of 1, so I don't need to do the grouping. I can just go right to my factors. So 2 numbers that multiply to negative 20 and add up to negative 8. Negative 10 and positive 2. I'm just going to move this out of my way for right now. All right, so remember in the original directions it said set all factors even variable GCFs equal to 0. Since I factored out a GCF that's a letter, that needs to be put equal to 0 also because that's going to give me a solution. That's a spot where I can plug something back in and do some math. Okay, if my GCF is just a plain old number, I don't need to do anything. So if I factored out a 2, let's say a problem had a GCF of 2, I'm not going to say 2 equals 0. That doesn't make sense. So I'm going to put this equal to 0. I'm going to put the x minus 10 equal to 0 and the x plus 2 equals 0 and solve them all. This one's just x equals 0, x equals 10, and x equals negative 2. So I do get 3 answers here, but if you go back to the original problem, that makes sense because it's an x cubed. However many variables there are how many possible solutions there are. They may not all be pretty, but as we get into our polynomial unit where we will be solving higher exponent polynomials, you will see that. So that's okay that I have 3. All right, the last one was 4x squared equals 49. Or was it just, I think it was just x squared, sorry. Yeah, just x squared equals 49. Okay, sorry, let me just fixing my writing. Okay, so this one, guys, not factor, square root it. And it's already isolated, so literally just square root it. So x equals a pod over negative 7. You're done. All right, so pause the video, please. Go ahead, try these 4. Be careful on number 7, but give it a shot. And then when you're done, you can press play and check out your answers. All right, let's take a look. Definitely good practice because a lot of these square roots, guys, ended up with i's, so you want to make sure that you understand what's going on there. But in number 5, isolated, I ended up with x squared equals negative 12. So when I took the square root, I had to pull the I out and then reduce the 12. Okay, so you can see my answers there. In number 7, you might look at it and go, oh, I should FOIL first. No, you're making more work. If you notice, you need to start getting comfortable seeing that sometimes it's not just x squared. It might be a binomial squared. And for now, I'm going to treat it that way. If all else fails, I could try to FOIL it out and factor, but it's not going to work. It's not factorable. So we're just making more hard work for ourselves. So here I can move the 32 over, divide by 2, and then I can take the square root. Okay, leaving me with 4i and then move the 3 over. So remember what I did here, sorry, that should no longer be a squared there. That marker. Okay, so what I did here, guys, was I added 3 to both sides, right? And then we know that we write complex numbers where the real part is in front of the imaginary component, so that's why I put my 3 first. You can pause the video anytime and replay anything you need. Number 6 was factorable. There is an x term, so it's not like I could square root if I wanted to. So that's what I ended up with. And then in number 8, move the 8 over, divide by 5. Oh no, ugly fraction. Just leave it, and then you know how to isolate, or you know how to rationalize a denominator. You know how to take care of a negative under a radical. If not, you definitely need to be coming to work with me because those are things that we should be able to do. Okay. All right, we are done. Any questions, please come see me.